Welcome everyone to the panel discussion for the Code Undergraduate Design Conference. The topic for today is architecture in the age of AI, and I'll quickly introduce all of the panel members. We have Tania and Leo. Tania is from Newcastle University, currently completing a PhD. Leo is here from UNSW and also works at HDR. Also completing a PhD here in the faculty, and we have our esteemed keynote speaker Jane Burry, Dean and Professor from Swinburne, Marc Aurel, who's come over the ditch from New Zealand, from Victoria University in Wellington, Rob Asher, who comes to us from Cox but also represents the startup Giraffe, and Anycie Coorey, from ArchiStar, which is great. So we have a really broad range of panel members to start this discussion off. So, architecture in the age of AI. It's predicted that so-called AI applications are going to take off across a range of industries really rapidly in the next 3 years. And there's discussion about the potential implications for this, wide-ranging implications for ways of working, the composition of the labour force, and the very notion of work itself. And by extension, then, there are also implications for education and notions such as lifelong learning. But it's worth remembering that AI, or artificial intelligence, while it is a young term, a field that was popularised around the mid-20th century in the aftermath of World War II, and in the context of a society that had gone about killing millions of people in that context, it's also a very, very old concept, and many cultures have projected ideas of human notions of intelligence onto inanimate objects. So it's both a young term but an old concept. So we're going to kick off this discussion by thinking about what we mean by AI in 2019 and what we mean by AI in the context of architecture. And I think I have an instruction for who gets to answer this question first. So we'll start with Tania, first of all.
We all know that the notion of artificial intelligence is a broad sense, and we think that it's a new science that probably help us operate in a different way. So artificial intelligence is a term that describes performances that mimic the human behavior or human thinking. But I like to think of it as an extra agent that has its own body with robotics, has its own mind with machine learning, and has its own communication skills with natural language processing, with its own voice of Siri or whatever agent happens to exist in the market. So probably I think that it's a collaborator that takes advantage of the vast amount of information that is around us, and it has a tolerance for errors. So it doesn't oversimplify rules. It doesn't have to invent some simple condition to explain what is happening, but it takes in account whatever is happening in order to come to some kind of conclusion. And this is where it becomes useful to architecture. It probably provides some interesting correlations and conclusions that we either not aware of or we had some kind of suspicion that it might happen. So I think of AI as a collaborator with an optimistic perspective of the term. And I kind of disagree with the notion that we are going to be extinct in the future.
Great, thank you. So Leo, would you agree with that, or do you have a slightly different perspective?
Yes, from my perspective, AI is actually quite down to earth. Like maybe you all experienced AI in some way in the last 10 years, 20 years, or maybe from the birth or the first day you were born. Like I think decision tree is sort of AI. It's just a single arithmetic logic that For example, do you want to have spicy food or not? If you choose no, do you want to have something with soup or not? And if you choose no, maybe do you want a French or not? It's sort of just the logic keeps going as a decision tree is sort of a form of AI. And we can also say computer making predictions are AI. But after all, it's algorithms that make predictions using data. So it existed for a long time, and it will keep going for a long time as well. It's the recent machine learning breakthrough, especially neural networks, that brings the public into attention of AI. And especially when Google Brain team actually created the AI agent that beats a lot of Go player, such as Lizzie Doe, and the media started publishing papers about how AI beats human, that really makes the entire society nervous about AI. But from my perspective, it's been there for a while, and it's purely about how to make data more useful for us. So there's no point for us to be panic about it.
Thank you, and over to you, Jane.
Thank you. Well, just sort of continuing with the thought that computation is that cerebral annex, AI is kind of the friend we all have been wanting for a long time. That's now is very intuitive and sort of tunes in. So I also am very optimistic about it. I kind of think voice recognition goes back to the 70s, and it was only kind of useful under very narrow conditions, and now it's getting quite good. Some people can cope with it. Some of us are still struggling with Siri a little bit, but Alexa is kind of more friendly. And obviously AI has sort of cracked vision recognition. Why? Because it was really important for security applications and things, so a huge amount of money's gone into that area. So if we throw enough resources, we can get things to work really, really well. I would say like 2015, it was much better to do image processing through AI than through any other means. And now the struggle at the moment for architects is to think about exactly how we're going to use this capacity in architecture. And that's slightly less obvious, but we've seen some great examples today. So thanks for that. It's been really kind of thought-provoking to see what you guys are thinking about and how you're looking to use those genetic algorithms and machine learning to move things along and get rid of some of the drudge, you know. That's what you want a friend for.
And what's the situation or the view in New Zealand on AI?
The situation in New Zealand, no, I don't think it is a New Zealand phenomenon. It's more a global one. But we're looking at AI very much from a human perspective, but not from a perspective of all living on the earth. And that's very much also an architectural perspective. We build for humans, but we don't build for other living beings in the world. And I think this is with AI allows us to rethink what do we build actually, and how do we build, and is it only we inhabiting the world, but there's other species on the world that they also want to live, and how can we actually form a collaboration with them? And AI is then one player, becomes one living organism within this ecosystem. Yeah.
In practice, I'm similar to Leo. I think I look at AI very functionally, like a selection of algorithms, like a gradient boosting or a decision tree or regressions or something that basically mimic the human mind. And I'm not too worried about them because they're dumb. You know, Siri's not going to take over the world anytime soon. Like my mum's called mum in my phone, and I can't call her with Siri because I say call mum, and Siri goes, "Who is your mum?" And you can't say mum's mum. You have to give your actual name. And if I think about how much money Apple's put into that, it's terrifying. So I think they're very, very powerful algorithms in kind of really bespoke or controlled environments like a Go match or vision, image recognition. Even self-driving cars, they're sort of making changes. But I think the architecture domain is complex and sort of multifaceted enough that there's another few years of human intuition needed. You know, you've got to figure out politically what your client wants, as well as some structural stuff and some blah blah blah. So, you know, for the AI to reach that level where it can operate effectively in such a complex problem space would be something impressive indeed. But definitely in sort of like laser-focused applications of algorithms to eliminate drudge and be a friend, I think that's where it's awesome.
Okay. At ArchiStar, we love AI. We're very pro AI, simply because we use it for evaluating design on a large scale. So pretty much, rather than an architect or a developer going through, you know, 1 or 2 designs on a site and saying, okay, well, how does it rank for sunlight? How does it rank for privacy spacing? You know, ventilation analysis. You know, all your kind of building ratios, that sort of thing, and saying, okay, well, you know, okay, I can do this, you know, via a human, you know, in a week or a few days or a month even, who knows? Or I can analyze thousands or millions of designs in, you know, 1/10 or even less of the time. And without AI, that wouldn't be possible. So we're very pro AI at our work, and yeah, we're very excited for all the new things that are coming in the future for many reasons, simply for that processing capability, but also for the accuracy that comes with, you know, analyzing good data. And I say good data in that, you know, if you start off with bad data, the whole process of AI is kind of useless because, you know, in terms of like, you know, yeah.
What's bad data?
Bad data in terms of, you know, inaccuracies. So you can get, you know, for example, when we import into our system, you know, your street lots, your government street lots, some of them might not be accurate. And if you start with a site that's not accurate, kind of your whole system from then on becomes, you know, all your analysis is off. So yeah, so we love having good data, and AI is perfect for that because we can take that and go from there. And that's it. Yeah.
Thank you. I just wonder quickly if all of the panel could reflect on maybe an alternate name for what we're talking about. If you weren't allowed to call it AI anymore, what would you call it? How would you describe it?
James?
Sorry?
James? John?
Okay.
I would call it data science.
Okay.
Oh, I just thought of what I'd call it, and it's completely slipped my mind. I guess I'd call it kind of meta processing.
I see it probably as my partner in design.
Okay. Collaborator.
Yeah, but that means that I'm really active interaction. But I think, you know, we all can act independently. So it's more partner. I go when I need it, and I not when I don't need it.
Yeah, I could just call it computer science or algorithm making.
I'm going to say data assistant or design assistant, I think.
Okay, so we can hear obviously a lot of emphasis on the data there. The data is really central to our ideas about what AI is, particularly in architecture. So I'm going to move on to ask Jane and Marc if you could comment on how you understand ideas connected to or methods connected to AI are currently being taught, apart from maybe what we've seen today, in university and architectural education contexts around the world.
Right. I think that architecture education always hinks behind what is actually needed. And that's actually a huge problem. And many schools, they don't teach any coding. And one can actually now question what's more important, to sketch or to code. And I don't want to engage in a discussion between, you know, hand drawing, whether the value of it and so on. But I think that understanding what coding is and what an algorithm does and what a computer does and how the computer actually communicates is actually essential for us to manipulate and to generate the design, so that we actually have the partner in design. We have to know how the partner works and thinks, and we be able to communicate. And I think this is where the the current architectural education needs to shift dramatically to think how the whole idea of coding, of how the idea of using computational means in a way not for the production, but actually in the creative way of to generate the design and to generate interesting problems can be handled. So I think that's a fundamental thing. Then later, we still engaging very much in a traditional workflow in terms of how we teach architecture, and you go out and you do your design and you design a kindergarten, and then you get the feedback from your tutor. But that's not what reality is in architecture. We're not designing single one building. We are always in a team. We have a different construct, and we don't think about of how the design is communicated and evaluated. There is not in an office, in a practice environment, is not then somebody who comes and gives you a tutorial and gives you a feedback on that. I think we have to question more of how we can use the intelligence which is through data models and through the computational resources, how that actually allows us to self-evaluate the design and how we can learn about design. So it moves away from the conventional method of studio teaching, where we have a group and there is a master and you have then the trainees, but where the computer becomes actually partner in that design learning and in the exploration of it. And you could actually go even further and say what Uber did to taxis and transport, what does it mean in terms of learning and university? So we can go out and have all kinds of courses online, and we can see that and learn. We don't have to come to university. We can learn and we get all this information elsewhere, but we still come to university. So there's two things, probably because of structure and we're so used to it, that's where you have to go and you need a degree from that university. It's not enough that you go somewhere and say, well, I watched all these tutorials online. But it's probably also the social component, and that becomes very interesting in terms of the learning and what the artificial intelligence is not giving us in that context, how we actually socially interact. And I think that is also, when you go back to the profession, the interesting part. How do you socially interact? You have your workload and you have to do your things, but you work in a team, you work with different stakeholders, and it's all about the social interaction, and that becomes actually the value why you go to work. Well, it's the money too, but there's something in that context. And when we now currently educate people, we're not putting the focus on that social interaction and the social intelligence. We put the emphasis on the intelligence of the subject, what you learn. And the social, that comes somehow on the side. And that's great that we're able to do that and capture it, but we could actually shift it around, that we put the social interaction much more in the center and surround us then with the different resources which are online or or generate by ourselves, and shift that in the education.
So you were actually talking about that in primary schools yesterday, which was
yes, exactly. Yeah.
So for me, it's all about data, I think, and actually, the better things get technologically, the faster the data cycles are. I mean, we've always had very fast political cycles, but that seems to be even more sort of heightened in the current political situation. Well, it's the same in universities. We have data on how many of you have a job within 3 months of leaving university. And actually our funding is even driven on those kind of metrics. They might not be very good. Very few of you might fill in the form. So it might be very poor data. In fact, I very rarely see really good data. I got to say, I see a lot of really suspect and poor data. But so there's that driver. But if I've thought about this a lot because we just started a new architecture program, and what should an architecture program be when you start it in 2018? And you think, well, it's actually really impossible. Like, what will people be doing in 40 years' time? I mean, in 10 years' time, we might have quantum computing, and most of the sort of current really sort of major issues around processing and things will just be completely different. Hopefully they will be different. Hopefully we won't have the sort of vast data centres we have now guzzling as much and making as much carbon dioxide. So how do you educate people so that they are not obsolete in 40 years' time, but that they also have a job in 3 months' time in practice, which is still kind of operating on a very traditional model, and even in the computing sense is just really an analogue of much older practice in most cases. Of course, there will be some, and you guys are specialists, and hopefully you will be lapped up by practices who are looking for specialists within their research groups or within their computational groups within practice, and I'm very optimistic for you in that. But it is very difficult because you still have to cover the bases for now. You can't actually educate somebody for 40 years' time, even if you knew what 40 years' time held. So it's that sort of hedging your bets. And all you can really do is give people a kind of openness and a vision, and as Marc says, a sort of idea about how they're going to access the resources that they need to stay current, at least over the next 20 years before they're in management and kind of really doing terribly boring traditional stuff, as we do when we get further on. So yeah, it's quite a tough one, but I think what I see from my own kids who are sort of hitting 30 now is that they did a certain amount of university and then they had all sorts of changed ideas about careers once they worked, and they have gone back and done MOOCs and boot camps and re-educated themselves very fast online, and even the people that you talk to in your Uber are doing that. So it's sort of giving people that agility and that flexibility and that openness to be very conscious of what's happening in the mega scene at the same time as preparing them to be able to function right now.
Okay, so on the back of that, and with two representatives here from the AEC industry, operating in probably similar ways, but maybe with slightly different philosophies at the foundation. What do you see as the skills that will be valuable to furthering the profession, or should we be talking about disrupting the profession? Or what skills do you think this generation needs to have? What are you looking for?
At ArchiStar, we kind of see we have two sides of the spectrum. You can be on the designing side where you use the tools that are available, so your Rhinos, your Revits, or your coding kind of tools to kind of get ahead and use these tools to create all the cool buildings that we see kind of all around the world today. On the other side of things, you can be on the tech side, really, where we kind of sit at ArchiStar, and that's pretty much creating the tools that architects, builders, developers need to create these designs and create these programs. So we kind of see having, those two sides of things. You can be using the tools or creating the tools. And I think for both of those elements, the key things you need to kind of know are the ability to continue learning, I think. So what we do at work, we like to fail fast and learn fast. So pretty much go online, research the things that you need, use those tools, and if it doesn't work, okay, toss it out and start something fresh until you find something that actually helps what you're doing. So that involves a lot of coding, using a lot of programs that involve code. So you have your Rhino, but you have your Grasshopper that plugs into it, or if you have Revit, you have Dynamo that plugs into that. But in terms of that, we use a lot of C# and those kind of tools to actually kind of get ahead in what we need to do. And we find that there's no one tool to be fluent in that's going to help, get to your solution, but rather having a lot of tools mixed together and having the ability to combine these tools to make things work. And that's where we kind of find that value. So when we look for people to hire, it's mainly not a person that's just fluent in, one thing, but, a person that knows a lot about a lot of different things, or even a little about a lot of different things, because by showing that, it means that, you have the ability to learn, and that ability, it's important. I think that's the most important thing we find right now.
Yeah, I agree with the comment, like the ability to learn. I think that what I look for, or what I see as important, is you need to go as deep as possible, as quickly as possible. So I sort of take the point that things are going to be different in 40 years. I think if you brought Corbusier and pointed out all of these buildings, none of them would surprise him. There's no formal language here which he wouldn't be fully conversant with. So I feel, and he, I don't know, he's hopefully been dead 40 years. I don't know how long he's been dead, but there's a continuity as well as a disruption. So, the surface area of a sphere to its volume, that ratio has been the same, since before the Big Bang and will outlive us. So there's certain eternal kind of principles, and there's certain things which actually end up lasting a very long time. One of my favourite things to do is read the guys that started the computer revolution. So the mother of all demos was in 1968. They demoed the mouse, they demoed online sharing, two people editing the same document at the same time, folder structure. So you can go and watch that demo. It's not like I forget the name, but it's a very famous demo. It's on YouTube. None of the computing concepts that we have today would have surprised those guys in 1968. So there's this massive continuity of thought. So you actually don't have to learn that much. They were using the same, what's a for loop? What's a memory pointer? What are the logical and, or, NAND, NOR, XOR, XOR? All the deep things you need to know are actually quite static. So if you learn SQL, structured query language, that's a 50-year-old technology. You don't have, that came out in 1970, and that'll still be used in 2070. But if you understand the principles and the depth behind it, you're a devastatingly effective operator. Because then if someone says, it's in Python or it's C#, it's all the same. It's just all the same, right? They're all sitting on the same architecture. But you have to have that kind of hunger to get to the depth and try and find the things that last a long time. And I think that's what a university career can give you, or the time in university is to get the depth. But then when you're out in industry, you have to be super shallow. So you just have to be able to pick up a tool very, very quickly, use that tool to achieve an end, and achieve it very quickly, and then discard the tool when it's, Revit 2020 comes out. There's no point learning Revit 20, whatever it is, right, or ArchiCAD 8. So the best things I see, the most successful people that I see and the people we try and hire are people that have a deep understanding of the principles of something, and that deep foundational understanding allows them to be very flexible at the surface level, because they can see that all the surface stuff is just another representation of an older principle.
So what I'm hearing, I could be hearing it wrong, is something to do with questioning, with investigation, with inquiry, and curiosity. So question to Tania and Leo, perhaps, is with developing understanding of where AI technologies can go, whether that's data, algorithms, machine learning, sensing, what role will curiosity play? Will we be usurped in our ability to be curious? Does that make sense as a question?
Yes, it does make sense, because I think that what AI is doing is transforming the questions. So instead of asking how something is happening and inventing rules, we're asking what is happening. What are the minorities that we're not taking into account? So it's changing the form of questions that we're setting, and probably that will change the way that we're thinking in order to start asking different questions, start exploring differently things. Mm-hmm. And probably you had a very good comment before, like AI probably will eliminate all mundane things and probably allow us or give us time to go into depth, into a very rigorous analysis of really interesting problems that we don't have time or we do not know how to address at this state, or probably reveal some kind of interesting correlations by coincidence from this vast amount of information. So it's a very critical tool that we have to explore.
What do you think in architecture it will show us that we don't already know or that we can't know?
Probably I think in architecture we're kind of safe yet, because we have this open-ended element that AI cannot address very rigorously yet. So we will probably have more time to forget about spreadsheets or forget about cost estimations or forget about some kind of condition of where the bathroom should be in some house. But we have to think of what this house does to us, how this house operates back, how this house is personalized to our own senses, our own condition, our own probably choices. So I think that we are going to shift towards what the objects or creations of our thinking do.
Thanks.
I think potentially AI can help designers to focus on design rather than other stuff. Architecture nowadays is actually situated in quite heavily regulated societies, and like ArchiStar and Giraffe is doing, part of AI assistance to architects is to being able to quickly test and verify if this design option is viable. And from a greater sense of what AI can bring to us is, I think it's a tool, essentially. And the tool will be able to make us less worry about certain technical difficulties. In 1980s, when Frank Gehry needs to achieve a building that looks like a fish, they need to find someone who is doing aerospace modeling and hire them to use some very specialized software such as CATIA to do it. But nowadays, anyone in this faculty can actually use Rhino to achieve very similar result. I think it actually lowers the technical barrier of one to achieve its ultimate goal by introducing a more advanced tool.
I just wonder what your perspective then is on AI being a tool and being able to expand. Does it make us potentially super architects, superheroes in the architecture field?
We need a cape.
Well, it depends if we're trying to solve the right problems, you know. And I really take your point that we're finally kind of building the city that Mies envisaged 100 years ago. So it does make me wonder if in 100 years we'll actually be building with mycelium. But if we're not, we're sort of hitting the buffers with a few kind of major material and environmental issues right now. And we just won't be here unless AI is going to help us solve those problems. So it's really about how we frame the problem, I think, and you know, and that's the tricky part, is that it always learns on the basis of historic data. So it's that project. Maybe we still have to do the future gazing and the projection to think about how we direct that.
Yeah, that's in the stock exchange. You can see all the graphs, and it only says, you know, the past performance can't give you what the future performance is, right? But that's probably the question whether AI actually can address that, because we are sort of able to project something in the future or make certain visions out of it, some of them coming true. But I think that AI is actually able to take the information and abstract certain things from the past and project it in a way to the future where we actually don't see all the details, because it just can take much more parameters and many more variables to come to an outcome. But if we also look at how we actually communicate, in earlier times we only communicated face to face, and maybe we were writing a letter, and then came telephone, and we had that one, and it was very expensive, and then, you know, more media came. Now we have probably 20, 25 different channels of how we communicate a message, an idea. And if we only hear it from one message, we don't take it as, that's not the news, that's not really the information. We need several. But that is probably similar of how AI works, that it's not only taking one data source and goes very deep and says, well, that is now what it is. It takes really a variety of information and puts them together to form actually then the message. And I think that's very interesting, that we as human moved into a realm where we use very different way of how we communicate and how we gather information. And then we have AI, which uses now a similar system in this context. And so I wonder for myself how now in 50 years, how we communicate, because AI is there and allows us to do certain things and gives us other information, and how that then influence the future AI.
So, speaking of the future AI, Tania and Leo are both doing research connected to these ideas. What are you researching? What are you trying to find out?
My research is based on urban geometry. So I'm trying, and my basic topic is autonomous cars and the future implementation. So I'm trying to identify areas that underperform under specific factors. And I'm achieving this by comparing geometries from all the cities in the world in similar population. So without the help of AI, that could not be possible. So I probably have something like maybe 1,500 cities to compare every street and every building and every land use that is happening there. Without AI, this is not something achievable. And what this colleague gives me back is it identifies the features that underperform in specific areas. So if we think of a polycentric urban environment, I can identify if it has low public transport or low urban green or low public space or low walkability factors. So some other probably, I have around 20 factors that can be identified, but the thing is that this cannot happen without this tool. And what the other thing that AI is giving me is that it's a new approach. I cannot find many precedents. I found 2 or 3 studies, and all of those studies are from other disciplines. So they come from medicine, or they come from transportation, civil engineering, and my background is architecture. So this tool allows me to probably utilize their findings, their tools, their way of doing, their methodology. So I think that it opens up this conversation to other disciplines. It opens up questions to different audience, and it unifies the language. So probably if we want to say something to a doctor about urban health environment, they will understand. And that's pretty critical.
My theme of research, because I'm still first year, haven't got my confirmation review done yet, is to use reinforcement learning, agent-based modeling in urban design sense. What it means is basically, quick show of hands, how many of you actually play SimCity before? Or any city planning games? Okay, so I'm talking to the right people, most of the right people. So basically, I want to create a sandbox system of urban design that use AI to simulate the development process. So for example, if I put train station here, what happens near this train station in the next 10 years? Traditional approach would be, not traditional, but established approach is using agent-based modeling, using rule-based agent-based modeling, such as if what happens, go yes. If what happens, go no. But it has certain limitations and take a lot of computational power. So can we use reinforcement learning as a new way of verifying, examining this similar process? And I've been inspired by a few key researchers, especially what Google Brain Team is doing in terms of doing in terms of experimenting with reinforcement learning. They had a recent video released on I think it's called AlphaZero. Basically, they put a a sandbox of hide and seek game, and put few agents of 2 teams and let them to play hide and seek. And later, the agent itself learns to come up with tricks that no human can actually predict. So it sort of forms an emergent behavior that we never expected to do. So maybe we can use this type of AI to predict a more accurate future. That's my hope.
You can also jump in with comments anytime. But I guess the next direction I wanted to take the conversation was, okay, so we're doing quite a bit of research in this area. We understand that there are numerous applications and opportunities to open up the way we understand the world and the way we could therefore design in different ways. What are the barriers then to actual real-world industry applications for AI, given that we understand AI to encompass data, machine learning, algorithms, to be an umbrella term that really captures a lot of those different things. What are we coming up against? What are the challenges?
I'll give a bit of background into kind of what we do at ArchiStar, and then I'll kind of bring in why we have issues in some places. So pretty much what we do is that on any building site, we can generate buildings that are compliant according to a set of rules. So it might be your planning controls or other controls that you input into it. And then once we have that building, we can do a whole series of analysis on it. So, sunlight analysis, privacy spacing, ventilation, that sort of thing, like I mentioned earlier. Where we come into issues is pretty much, like I said before, with the quality of the data that comes into it. So with AI, with our algorithms, we can do a whole series of analysis. And that's kind of like our main section of what we're doing. So even like finding and selecting sites or looking at compliance of your building on a site, not just for one site, but for hundreds or thousands or even millions of sites or options on that site. However, if we don't have the right data in the first place, all that kind of information that we can provide using our tools that we've created and the tools that we're continuing to create, it becomes invalid. So it's really important for us. That's the biggest issue we kind of have. It's not always an issue. Sometimes it's great, depending on where you are. But it's not just your local kind of data, but it's your global data as well. So we're expanding into Canada, the US, parts of Asia. It's about where we can get the best data and how often we can update it and ensure that it's correct. So it's pretty much that scalability kind of tool and how that stays current and correct. So that's probably the biggest issue we're seeing with AI, not really the tools that we can create with AI, but the information we can plug in the first place so it can learn correctly.
Yeah, I mean, I agree with that. I think data, good quality data is a resource that's only sort of recently become valuable to people. So, if they were using the cadastral map to print out maps that were paper, there was a less, if cadasters were misattributed in the database, no one really had a major issue. But if you misattribute them now, then it can really foul up the system. So data quality is a big thing. I guess the idea of AI is that it can deal with mess and ambiguity and understand that, but that is actually much harder than it sounds. For us, I think there's no real barrier to AI. It's these technologies are generally developed by Google, Apple, Facebook, someone funded by the US military ultimately, and they spread out of California and they're free basically. So all the Python libraries, PyTorch, scikit-learn, all of these libraries that actually do the grunt, which everyone closes over, are massively funded and have spread worldwide. Everyone uses them. We use them all the time at work when we can, and people are hungry for it. Clients are hungry for it. The directors of Cox, for example, love putting up AI or anything with the word tech, data. You say it, it's fashionable, it's hot right now. So I don't think there's many barriers except sort of time, and it's growing at such a pace that that even that it couldn't really go faster. I think the real absence that I see is there's a lack of understanding about what it actually is. So people love it, clients ask for it, but they don't know what they're talking about often, and often the people who are using it in quite a shallow way.
What do they think it does or is?
Well, like AI, if you Google it, it's like a blue and white picture of like a see-through brain or something. That's what data is, right? And then they think it will solve a problem. And the hard work is formulating the problem and understanding what you're trying to ask and knowing, hey, if you only consider these 5 parameters, those are the only parameters that'll get considered. If you don't consider non-human beings, they're not considered. And if you don't tell the AI to consider them, it won't consider them. So the real difficult work is formulating the problem, and then the tool comes in, to do what the tool does in its really defined way. But if you set it up wrong, garbage in, garbage out is the famous computer science term. If you ask stupid questions with bad data, you get stupid answers. The worst thing is they look like they could be okay, and they came out of the computer, so they must be real. And you see that all the time. So embodied carbon versus operational carbon, depending on what you measure, you can have a super green style building that's actually that's actually put way more carbon into the atmosphere than it's ever taken out, and will still be lauded and win awards. So I think that's the dangerous thing. There's a famous quote from someone who's like, to err is human, but to really foul things up, you need a computer. And I think that is 100% true.
Okay, so we're closing in on the last few minutes. I wasn't told whether I was allowed to offer the audience any questions, but I might just throw one more question at you. What about data ethics? Is it okay to be using all the data that we can use? What kind of frameworks do we need to think about going forward in terms of data use and data exploitation?
That goes to me?
Anyone?
Not everything that can be counted counts. And the data that are in the world are too many and more than we ever need. So even if we use a small percentage, as we've seen today, we can have some conclusions. But in the ethics part, we're already giving slowly authority to AI. We're meeting people through AI. We are talking to people through AI. So I think it's a personal choice at the end. And the only condition that should be applied is how we as individuals authorize or not. And then it's this collective behavior that it's emerging. How many of us will authorize? And then it challenges democracy probably. And then what if there is a 20% that does not want to follow? Then is this anarchy in the new world or not? So it's a political, ethical, more complicated thing. But I think at the end it's an individual choice that we have to make. And we are making it slowly, but we don't take into account that when we agree to terms in a site to use our information, we're just giving up this authority. So it's a personal, it is a conversation about more broad discussion about ethics, but at the bottom line, it's a personal decision.
I'd like to acknowledge what Rob said. Data is more and more valuable nowadays. It's a new type of asset, and how we treat this asset, just like our houses. And it is sort of interesting to me. I'm waiting to see what happens, but yeah.
We have an ethical responsibility to collect a lot more of it and much better data. That's what I reckon. But obviously I kind of support the privacy laws that are ever tightening up and constraining what we can do with data. But, I think every building like this should be constantly collecting occupancy data, for instance, and we should be responsibly looking at the way, given all the crazy redundancy that we build, we should be looking at better ways of using that, because a lot of that could actually solve a lot of our environmental problems passively without using active systems, for instance. And we do I'm sitting here freezing right now. I'm being blasted by air conditioning, and I think, man, we're doing all this research on microclimates and personal microclimates, and we have the knowledge and research. I don't know how that's going to translate into any kind of commercial reality. But I just feel I think the first point about the quality of data is the one that strikes me. And if we can solve kind of quality of data and actually collecting the data that we need and not people with clipboards, then I'm sure we can keep on top of the privacy thing if we want to. And it's always about will, it's, WikiLeaks, we won't go there. But, it's really political will at the end of the day.
Do you think in architecture, architects can be persuaded to share better?
Architects can be persuaded in what context? Because
to share their data.
Well, they shouldn't. That's one of the problems, isn't it, of working is if it's valuable, and architecture architecture professionally is struggling with its kind of identity and its presence in the marketplace. They obviously have to tread carefully in terms of sharing their data, but it depends which data we're talking about here. So again, we have to have some sort of, in terms of ethics, we have to think about who owns data when we collect it, and how it can be used and how it can be licensed, and that has to be tied up very carefully.
Yeah. No, I think that we don't have any discussion around the ethics of data. And I don't think that we have the choice of we want this data given away or not, what you said, right? You know, you travel and the passport control, they say, you know, you have to give your data, or you can also refuse it. But if you refuse, you cannot go on the plane. I said, well, what is it then? You know, you're putting an oxymoron there. So I think we don't have a discussion. We need a discussion. We need a much higher ethical standard around data. I certainly agree that we should use the data for the good, right? But that is always the thing, that you use things for the good or the bad. So if you have data about how this building is used, sure, that can be very good data. But it can be also the other way around, that the university say, well, look, this building we don't need, and we do teaching differently and we do learning differently, and suddenly it has implication of how we actually learn and use in our environment. So it becomes very restricted in terms of how we can use the urban and the architectural environment. And this is because data is there, data is commercially used, and by that it's captured, but it is not discussed in any ethical or in any political context that we really have a say in that. And I think that is absolutely needed. And for example, when you go it really to an extreme, what's happening in data collection in China, this you can see is be used with the idea to do something good, but it is at the same time, you know, used as a very control mechanism. On the other hand, you go to other places where they select data and give it out, and you can use that, and it done something very good out of it. Yes, we have to work much harder on that one.
Great, thank you. I'm just going to open it up to maybe one or two questions, because we don't have a lot of time left. But I thought if someone has a burning question in the audience that has not been asked ever, please put your hand up now. Come on, don't be afraid. Yes.
We've seen a lot of examples today of how AI and machine learning have been applied to the AEC industry, or whatever you want to call it. I was wondering, as we are coming into the professional world and as potential scholars, do you think there's any area of AI research in the AEC industry that is lacking, that should be investigated?
I had a bit of reversed life. So after the uni, went to the industry and then back to uni. I think that we all think that AI will take over, but what if we make it into an opportunity? So today we've seen assembly line conditions, we've seen post-occupancy evaluations, we have seen new fabrication approaches that all can have AI in. So probably AI will take over the job, but won't take over the tasks. So if you specify in one task, that probably is the answer that we're searching. Probably we don't have any formal assembly line design. We don't have any formal preparation for fabrication design. We don't have any formal, probably we do, and I'm not familiar with all this documentation for delivery of design. So those tasks are critical and can be enriched with AI. And I think that you are absolutely privileged from the majority of architects that are not into computational design. And I think that you will set up the foundation for these specific new disciplines.
Thanks.
I think the undergraduate of computational design are so privileged with such an amazing skill set. I was in the previous conference a few hours ago and been listening to all the good ideas about how potentially the technical skills and the knowledge you comprehend in a very short period of time can actually help to shift this industry. I think the answer I want to give you is, first, yes, you have a very niche skill that is highly valued. Second, why not think about being an entrepreneur? Why not think about how you can use your own skills to transform the entire industry? I think it has very huge potential.
I do want to thank all of the panel members for a great discussion and for our audience as well. And congratulations to all our third year graduates. We were really impressed with the presentations today, and I think they do paint a picture of where we can take these ideas in the future. And I think what came out of this discussion is that, yes, we need to anchor these technologies in architecture by identifying the problems first. That's actually what we are very good at, but is actually asking the question, finding the question, framing the problem, as you all know from the last 10 weeks, is actually one of the biggest challenges. So I'll just leave you with an off-cited quote, that technology is the answer, but what is the question, which is from Cedric Price. Thanks.